Good morning, my dear students. Our chapter number 12, electricity, and we are dealing with heating effect of electric current. Today we have the topic that is practical application of heating effect of electric current. We have seen little bit in our previous class, and now we are going to deal with practical application of heating effect of electric current. So let us start. Welcome you all once again. Practical application of heating effect of electric current. We studied how it all occurs, and we know that the generation of heat is an inevitable cause of electric current. The generation of heat, and what happens? It converts the useful electricity or electrical energy into heat. The generation of heat is an inevitable cause of electric current, and the generation of heat converts the useful electrical energy into heat. Is it good or bad? Just bad. So what happened? This heating can increase the temperature of the component. You know that in every gadget many components are joined. So this heating will increase the temperature of the component. As a result, this working of the component will change, or the correct word is, it will alter the properties. That means a change will occur for the working of the component if the components are heating. It is good. Generation of heat is inevitable cause of electric current. So it converts the useful electrical energy to heat. If it is in a component is heating for more time, it will alter its properties. So, is there any uses this heating effect we can use? Let us see how we can use it. Uses. We can use it in many appliances in our home. Which are they? Can you name one or two? Or shall I tell? Yeah. What about the case of electric iron? And in the case of electric toaster, electric oven, etc. How they work? We already just discussed in our last class about the working of electric iron. So today I am asking you to just think about the working of electric current, electric iron, and electric toaster, electric ovens, etc. Inside that, the electric source is connected to the coils. Okay, the coils of the metals having high resistivity. Due to this high resistivity metals are connected, it will get due to the high resistivity, the metal will get heated, and heat is produced more. And all, if you check the appliances such as electric iron, electric toaster, electric oven, etc., they produce heat, and utilizing the heat, we will use that for different purposes in our daily life. And this heat effect is using for producing light, I am saying. Will you agree with that? Will you agree with that? Okay, let us see how it produces light. The heating effect is used for producing light. In the case of, you have seen the filamented bulb. Nowadays, it is the number of filamented bulb in home are less. So, LED bulbs, etc. But filamented bulb, you keep in mind, filamented bulb. In that bulb, what are there? Let it be the bulb. Here is the filament. This is the filament. Okay. This is the filament and this is the bulb. The supply is coming. So, in the case of bulb, the filament, this is the filament, is get heated. Okay, the filament is get heated. It emits light. This part will get heated. If you observe the bulb while it is burning, you can see this part of the bulb is burning red. Did you see that? Due to this burning, the light is produced. And the filament won't melt at high temperature because electric energy is passing. It is of high resistance and high temperature is happening, is there in the filament, but it won't melt at high temperature. Then, a strong, now we are going to study about this filament. A strong metal with high melting point, such as tungsten. You heard about tungsten? Tungsten is used as a filament. Okay, is the strong metal like tungsten are used as filaments. Then the melting point of that is 3,380 degrees Celsius. Okay, the melting point is 3,380 degrees Celsius. 380 degrees Celsius is used for making the filament. That means only this much part. Okay, this much part from here to this thing. Okay, this area. And the filament should be isolated as much as possible using insulating support. It is made isolated by using insulated support. Then what about this area, the area inside the empty space inside the bulb, this area which I am just drawing with blue. What about this area? They are filled with chemically inactive nitrogen. They are filled with chemically inactive gases like nitrogen and argon. Okay, they are filled with this portion. Inside the bulb, that portion will be filled with nitrogen and argon, which are chemically inactive. For what they are filling, the inactive gases are filling for the prolong. That means how to for the long life of the filament. And in the case of electrical energy consumed here, most of it will be used as heat. If you see in the bulb when it is burning, it is the filament is burning very red. That means the melting point is 3,380. So that much it is burning. Okay, so it is not melting, but it is burning. It is most of the electric energy is used as in the form of heat, and some form, a small part is used as light. Okay, some part is emitted in form of light. Okay, let us go to one more use is there. Let us go to that part. Okay, let us see what are the another application or another use. The another use. Let me write it as fuse. Fuse. Okay, one of the another common application of heating effect of electric current is fuse. Then what is the work or what is the function of a fuse? It protects circuits or devices or appliances by stopping the current or stopping the flow of current when a unduly electric current comes. When a heavy electric current, some variation in the electric current comes, the fuse protect the circuit or the appliances. And how the fuse is placed? The fuse is placed in series in the device. The fuse is placed in series in the device. And what it is containing? Commonly, some fuse will be like this. A thin metal wire will be there. Okay, and two metal edges will be there, and a thin metal wire will be there. Okay, it consists of a piece of wire. A piece of wire in the center, and it is made of metal. Okay, it is made of metal or any alloy of appreciate melting point. Okay, it is having a good melting point. Okay, not a high resistivity metal. It is having a appreciate melting point. Such metal is used in the fuse. Okay, there is a thin wire which is made up of a metal, and for example, it will be either aluminium, copper, iron, or lead. Okay, the metal wire will be lead, iron, copper, or aluminium. And if a current larger than the specified value, okay, sometimes device is using 5 ampere. If it is 8 ampere current is flowing to the device, the temperature of the fuse wire increases. Okay, the temperature of the fuse wire increases, and what happen? This melt the fuse wire. This center wire will be melted. Okay, the center wire will be melted. So what happen? We know that if any components is moved from a series connection, the circuit will be inactive or broken. Yes or no? We are knowing that. So if a high temperature other than the device require is flowing towards the conductor, what happens? The wire will melt. Okay, the wire will melt and the circuit will be broken. So the current flow will stop. And the fuse wire usually enclosed in a cartridge of propylene or similar material with metal ends. Okay, we know that I already said the metal edges are there. Okay, similar metal edges. Okay, it will be enclosed in a propylene. Then, which are the types of fuses used in domestic purposes. That will be of 1 ampere, 2 ampere, 3 ampere, 5 ampere and 10 ampere, maximum 10 ampere. Okay. And for example, do you require an example? Okay. In the case of an electric iron, which is having 1 kilowatt electric power. Okay. Electric power is 1 kilowatt. Okay. A current I of 1000 by 220 ampere flows through the electric iron. That is 4.554 ampere is flowing. Current I is 4.54 ampere is there in the circuit of electric iron. Okay. Then in this case, a 5 ampere fuse will be there. Okay. A 5 ampere fuse will be there. Did you understand? And this is all about practical appliances of heating effect of electric current. And let us go through electric power. Electric power. Our next topic is electric power. Okay. We know that rate of doing work is power. Rate of doing work is power. This is also the rate of consumption of energy. Rate of doing work or rate of consumption of energy. Rate of doing work or rate of consumption of energy. And we know that H is equal to I square RT. We studied this equation. And also it is the equation 12.2 in your textbook. 12. Not 2.21 in your textbook. Okay. 12.21 in your textbook. It gives that the rate of electric energy is dissipated. Okay. We studied a rate of doing work is power or the rate of consumption of energy is power. And H is equal to I square RT. That is the rate of which electrical energy is dissipated or consumed in an electric circuit. Okay. This is also termed as electric power. It is also termed as electric power. That is rate at which electric energy is dissipated or consumed. Electric power, the rate at which electric energy is dissipated or consumed. Then the power is given by P is equal to VI. P is equal to VI or P is equal to I square R, which is equal to V square R, which is equation number 1, which is equation 1. Then SI unit of electrical power. Okay, that is SI unit of electrical power is what? It is watt. Okay. And SI unit of electrical power is watt. It is the power consumed by much larger unit. Okay. It is the power consumed by much larger unit. Did you heard about kilowatt? Kilowatt. In larger unit, we will say it as kilowatt. Okay. Kilowatts is equal to 1000 watt. Okay. 1000 watts. Okay. In larger, if it is consuming in larger, we will say it is in kilowatt. Then we know electrical energy is the product of power and time. We are knowing that electrical energy is the product of power and time. The unit of electrical energy, the unit of SI unit is this one. The unit of electrical power is, the unit of electrical power is electrical energy is, electrical energy is watt hour. That is WH, watt hour. The unit of electrical energy is watt hour. And what is watt hour? 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. The commercial unit of electrical energy is kilowatt. Commercial. Okay, commercial unit of electrical energy is kilowatt. Kilowatt hour. Okay. The commercial, and which will be given as kWh. Then 1 kilowatt hour is equal to 1000 watt into second. Okay, 3600 second is equal to 3.6 into 10 raised to 6 watt, and also 3.6 into 10 raised to 6 joule. Okay, and this is all for you today. You watch it, and our lesson is about to finish, and study well. Thank you so much.